In this lesson, we'll learn about arrays in C++. An array is a series of elements of the same type placed in contiguous memory locations that can be individually referenced by adding an index to a unique identifier. Like a regular variable in C++, an array has to have a type. And you will declare it as type, the name of the array, and the number of elements in the array. Therefore, if the type would be integer, it would be int. If it is float, it will be float, etc. The name, just like a variable identifier, has to be a valid identifier used. Which means that we would avoid using keywords that are available in C++. And then what is enclosed in the square brackets specifies the length of the array in terms of the elements, the number of elements in the array. That is what is enclosed. In square brackets. And of course, just like in any other regular statement in C++, it has to end with a semicolon. So if we would think about it in a picture form, we see this example. There are 1, 2, 3, 4, 5 elements of type integer in an array of integers, which we could call my array. So we have a valid identifier giving the name of the array, my array, which is type int because it has 5 elements of type integer. Note that I have here starting the first element with 0, 1, 2, 3, and 4. These are what makes up the index of the element of the array. So the number of elements is 5, but the last index of the last element is 4. Indexes always start with 0. Initialization of arrays. Well, you would initialize an array just like you would normally initialize a variable. But by default, there are some arrays that might have large scopes or a lot of elements, and you would leave those uninitialized, which means you would not declare the values of each element of the array. You wouldn't set a particular value because, of course, it would be very large. But in the case where the number of elements is very small, just like what I have here, 5, then it is wise to initialize the variable. And you explicitly initialize the array by defining or giving specific values to the elements of the array. So if we look at the example we had before, my array of size 5 or 5 elements of the array, we see we started initializing by enclosing the initial values in the curly braces. So we have starting at index 0, we have 16, then we have 2, index 1, 77, 40, and 12,071. So, and you close by having a closing brace or curly bracket and ending with a semicolon. That is how you explicitly initialize the values of the elements of the array. However, in C++, you have a possibility of not giving all the numbers or all the values of each element of the array, as we see here in this example. We declared that my array is of size 5, again 5 elements, but you notice within the curly braces there are only 3 elements. By default, the first declared value is always assigned to the element in index 0. So looking at it in a picture form, we see that 10 is assigned to the element in index 0, 20 to the element in index 1, 30 to the element in index 2. Now, because in the initialization there was no other declaration of the other elements, C++ assigns a value of 0 to the other 2 in the array. That's what the compiler does, automatically assigns a value because it knows the number of elements, because it knows the size of the array, so it would then match the numbers, including in the square braces, starting with the first index 0, 1, 2, and then assign 10, 20, and 30 respectively. But to the others, it will assign by default the value of 0. Now, accessing the array or the elements of the array is done by calling the name of the array and the index in square brackets. So this is the syntax: the name of the array and the index in square brackets. The index would start always at 0. Remember, the first element of the array has the index value of 0. So looking at it in the last example, in the previous example we were looking at, where my array had 5 elements, 10 being the index 0, 20 being index 1, then if we would call them, my array 0 has the value of 10, my array 1 being the index 1 has the value 20, and my array 2 value 30, and so on, because we didn't declare an initialization value of 3, index 3, then it's 0, index 4 is 0. So that's how it is referred. Again, at this point, it is very important to be able to clearly distinguish between the two uses of the square brackets that we have looked at in reference to the arrays. The first one is when we were specifying the size of the array, and the other one when we were calling the element of the array. So do not confuse this. When we have, for example, my array 3, we're saying we want the element of my array where the index is 3. In this case, the square bracket is used for the index. But when we declared the array and we said int my array, and we had a square bracket, we were declaring the size of the array. Sorry, this is a T. This would have declare the size of the array. Okay, that's the two uses of the square brackets. Now, going back to accessing the values of the array. Because you can access the value of the array by referencing the index, the values of this element can be assigned to any other variable, just as in this example where we're assigning it to a variable of type integer. Although this is not an array, we're just selecting the value of one element of that array, namely the one that is found in index 2, and assigning it to a variable a. With the same way, we can perform any operation with the elements of the array. Multidimensional arrays, well, those can be described as an array of an array or arrays of arrays. For example, one that is a bidimensional array can be imagined as two-dimensional table made of elements, all of them of the same uniform data type. The multi-array would represent a bidimensional array of 3 or 5 elements of type int, as seen in this example. So we have 3 rows and 5 columns. This will be a bidimensional array of 3 per 5 elements. The syntax in C++ to represent or to declare a multidimensional array is, again, the type, the name or the identifier, and then we enlist in square brackets the size of the number of rows and the size of the number of columns that our array table would have. Now, once we have that, the way to reference a value of a multidimensional array would be providing the index values in the specific element. So, for example, if we want to reference the second element vertically and the fourth element horizontally, then we would say, remembering that the index always starts at 0, you would start with multi-array 1 and so that's how you reference multi-arrays, elements of multi-array. At some point, we need to pass an array to a function as a parameter. So we'll discuss arrays as parameters. In C++, it is not possible to pass the entire block of memory represented by an array to a function directly as an argument, but what can be passed instead is its address. In practice, this has almost the same effect, and it is a much faster and more efficient way to pass the data. In order to accept an array as a parameter for a function, the parameters can be declared as the array type, but with empty brackets. So we see this as an example here, where this function type void has an array parameter being declared here of type int, but with no size specified. So the empty brackets, that's it. Now, another way to declare it is as what we see in the other example. Here in this example, this function accepts a parameter of type array of integers. Now, in order to pass within a call in C++, it is sufficient just to call the function. For example, let's say the first function of type void procedure, where it's receiving an argument of type int. it is just simply as just calling the name of the function and writing the array, as in this example, my array. Because here we have an example of a function, of an array that a size 40 called my array. So these are my arrays declared. We can pass it to this function above here simply by calling the function and giving my array. It is important to notice that again the type that this function is accepting is the same type as the array that is being passed. It doesn't matter that this is size 40 because in the declaration of the arguments or the parameters there was no size specified. Strings. We've looked at strings before, but we'll discuss a little bit more what is a string class. Strings are variables that store sequence of characters such as words or sentences, and it's very useful. First difference with fundamental data types is that in order to clear an object or variable of this type, the program needs to include the header. So in this example that we have here, we have a header file string being defined within the standard library. Once that is done, then we can declare a variable of type data type string, and in this example we're calling it my string, just like any other data types that we've discussed. And then we can assign a value by enclosing it in quotation marks. For example, this is a string. This is a string, includes all the characters including the empty spaces. So everything that's within the double quotation marks. And then we can, just like any other variable, perform any transaction or anything. Pointers. Before we have spoken about variables, we've said that they are pointing, or they are referencing a specific location in memory, and we said that the identifiers are what is used to name this specific location that contains some value. The value is what we're mainly interested in, and that this space in memory has a data type, and that's what we are variable. Now, with us using the identifier, we don't really care where that physical location in memory is for that data type and that data that we need to access. Hence, we use a variable. But if we would be interested in using this unique address, then we would come into looking at pointers, and we'll discuss that in a moment. Okay, the pause was because I had to charge my laptop. But anyway, let's go back to pointers. So we said that when a variable is declared in C++, we use the name identifier to find that specific location in memory to get that data that we're looking for, that value that we were interested in. We don't really care where that physical location is, but when we do, then we can use pointers, and we'll look at the dereference operator and the address of operator in this lesson. So in a C++ program, the memory is of a computer is like a succession of memory cells, each one byte in size, and each one has a unique address. These single byte memory cells then are ordered in a way that allows data representations larger than 1 byte to occupy memory cells that have consecutive addresses. Meaning, if we had an address 1, 2, 3, and our data is bigger than 1 byte, then it was maybe 16. It used 1 and 2. Okay, not 1 and 3. So this would be so that the memory can be found easily. Now, when a variable is declared, what decides where that memory address will use is not the C++ program, but rather the environment where the program is run. Meaning the operating system is what decides the particular memory location on runtime. But like we said, it will be important sometimes that the program obtains that address where that memory, objects of that memory where that data is location. In order to do this, let's look at an example. So here we have a variable in line 1 being declared or being assigned a value, my variable being assigned a value of 25. Let's assume, if we look at this picture, that my var is located in what is being represented in these little squares as the physical memory location. And let's assume that my var assigned the value of 25 is stored in a address physical location in memory of 1776. Now, the second statement here introduces the address of operator. Here, a variable called foo is assigned the address of my var. And how we assign a address of my var is by using the address of operator. So this is saying variable foo is assigned the address of my var. We said that my var, we're assuming, is stored in physical location 1776. So the value of foo will be 1776. Now, the last statement here, we have a variable called var is given the value of my var. Okay, this is a standard assignment operation that we already looked at in the previous lessons. So in essence, this is assigning the value of 25. So here, if we would look at it in pictures, then var somewhere in memory, we don't know where in memory, it is given the value of my var, and we said that my var is 25. So somewhere in memory where var is located, that value is 25. Now, however, foo stores the address of another variable because we said that foo is assigned the address of my var. And in C++, the variable that stores the address of another variable is called a pointer. And pointers are very powerful features of the language that have many uses. Okay, so the reference operator. Now, an interesting property of pointers is that they can be used to access the variable they point to directly. This is done by preceding the pointer name with the dereference operator, which is this asterisk. The operator itself can be read as value pointed to by the dereference operator. Therefore, if we look at the example we were considering, let's say a variable. So if we look at the variable bas, this is given the value pointed to by the variable foo. Okay? Remember that foo was pointing to the 1776, which was the address. Therefore, bas will be pointing to whatever the value is in 1776, and that we know is 25. Therefore, bas will be equal to 25. Therefore, we see this, that the reference and the dereference operators are thus complementary. The address of operator, which is the ampersand, and can be read as the address of, and the asterisk, which is the dereference operator, can be read as the value pointed by. Remember, so when you see the ampersand, you think about the address of this variable, and when you see the asterisk, you look at the value pointed to by this variable.